Welcome to Lesson 2 of Data Structures and Algorithms. Today's topic is variables and pointers. Here's what we are covering for today. We're going to look at the building blocks for data structures, that is, variables and pointers. Variables come in two types, fixed point and floating point. We will also look at how to diagram them with variable pointer diagrams. Here is an overview of how everything is arranged. As you can see from here, the core of building all the different data structures are variables and pointers. And the variables have fixed as well as floating types. On top of this core, everything else is built. Arrays, records, and building on arrays, records, pointers, and variables, you have arrays of records, linked lists, stacks, queues, graphs, and trees. First of all, what is a pointer? What is a variable? A variable is essentially a container with a name. For example, here we have a container. Its name is tin. We could put things in the container. Well, we can have different types of containers. In a tin, perhaps you could put some sardines. In a bottle, perhaps you could put some water. In a box, perhaps you could put some books. So, just as we have different types of containers to put different kinds of things in, we can have different types of variables to put different types of values in. An integer variable to put integers, and floating point variables to put floating point. Here's how we declare variables in C++. Here we have declaration of an integer variable. And we may put things in it like j is 23. Here we have declaration of two floating point variables a and b. And we may put things in it like a is 1.49, b is 99.1. And here we have a declaration of a character variable, c. And in it we could put the letter a. So it is important that you put the right kind of variable, that you prepare the right kind of variable to put the right kind of thing in it. So you put integers in integer variables, floating point in floating point variables, characters in character variables. Here is how we draw a variable. A variable essentially is a box with a name on top and a value inside. If the value hasn't been defined yet, we could leave the box empty. So we have the name and the container, which actually is stored in memory, in the computer's memory. And the contents inside, which is the value. So we will be using these variable pointer diagrams to represent all of our data structures in this class. Okay. What about pointers? A pointer is simply a memory location that contains, instead of a normal value, it contains the address of another memory location. So, variables contain normal values. Pointers contain addresses of other variables usually. And here is how we draw the variable pointer diagram for a pointer. We have, just like in the variable pointer diagram for a variable, we have a name, and then we have a container, which we draw as a box. But instead of writing in the value, we draw a dot. And this dot will be connected later to an arrow to point you to see where this pointer is pointing. For example, here we have a variable called John, and it is pointing to, we have a pointer called John. Here we have a pointer called John, and it is pointing to a variable called IN, and the IN apparently is a character variable containing the character N. So this arrow shows that John is pointing to IN And in fact, what is actually stored in the memory location here is the address of IN. By the way, in case you're wondering where do these names come from, uh, these slides are adapted from real graphs for the book Structuring Data and Building Algorithms in ANSI C, written by myself and Jonathan David White. So John is Jonathan David White. IN is his eldest daughter, IN, which actually means grace in Chinese. So her English name is Grace. What happens if you don't want your variable, your pointer to point to anything? Then we use the ground symbol from electronics to indicate that it is a null pointer. Actually, a null pointer is the value 0 in pointer. Okay? Just like you can have an integer variable that has the value 0, you can have a pointer variable which has a value 0, and that is the null pointer. This initialization of pointers that have no value to null means that it is possible for us to indicate that this pointer should not point to anything. And so when you're debugging your program, you can test for it. Okay, now we're going to look at some code which declares variables and pointers, and then it initializes the variables and pointers, and then prints each variable and pointer's address and prints the values stored in each memory location. As we look at this code, I want you to think about these questions. How do we visualize this in memory using a variable pointer diagram? What do these symbols mean? The ampersand symbol and the asterisk or star symbol. What do they mean in your C++ code? And then what are the steps that we use to use variables and pointers? How do we declare these variables and pointers? How do we initialize these variables and pointers? What happens if you put 2 asterisks? What happens? Can we use 2 ampersands? How is the memory allocated, and where would I need to use these pointers?
Here is the code that we will be using for this example. Right now, it probably looks very complex and confusing to you, but I trust that by the time I finish explaining everything, it will become clear. When we run this program in a modern computer, this is what you would see. A whole bunch of long hexadecimal numbers. The reason for this is that modern computers use 32-bit memory addressing for their programs. Actually, even more modern ones use 64, but the standard is still 32 bits when you run it. Now, if you look at down here, it's a lot easier to see. And the reason is that this is using 16-bit. 16 bits only involve 4 hexadecimal digits, so it's a lot easier to see than this huge mess here. So therefore, most of our examples, we will be using 16 bits, even though that's not how it is today. But you can see that there's a direct correspondence. So here we have FFF4 for Fred, and FFF2 for Ahmad, and FFF0 for Jim. And by this I mean the addresses. Whereas here you have this huge long thing which ends in 4 and 8 and C, which it's basically telling you the same thing but much longer.
Now, firstly, when I used to teach this live many years ago, I would call students forward to act this out. Well, I can't do this because you're all online. So what we have is we have an animation, a video, cartoon. And you can get this cartoon at this YouTube address. And I'm going to show it now so as to illustrate what's going on. Okay, so here is this cartoon. I'm going to play it.
First, we have to declare our variable. This is Fred and this is Ahmad. Both of them are integer variable. This is Jim and he is an integer variable. He has been initialized to 3. She is Zarina, who is a pointer to integer. She is Husna. She is a pointer to integer. She has been initialized to point to Ahmad. She is Polly. She is a pointer to integer. Now, Fred is initialized to 1. Ahmad is initialized to 2. Zarina is initialized to point to Fred. Finally, Polly is initialized to point to Zarina. What is star Zarina? Well, Zarina is pointing to Fred. Therefore, star Zarina is 1. What is star Husna? Husna is pointing to Ahmad. Therefore, star Husna is 2. What is star Polly? Polly is pointing to star Zarina. Therefore, star Polly is 1. What is star Polly? Polly is pointing to Zarina. Therefore, star Polly is the address of Fred. If we initialize Polly to point to star Husna, then star Polly is 2. If we initialize Polly to point to Husna, so star Polly is the address of Ahmad. If we initialize Zarina to point to Jim, then star Zarina is 3. If we initialize Polly to point to Fred, an error occurs. This is because Polly is a pointer to integer, not a pointer to an integer variable.
Okay, let me stop this video. Well, that's how we would do it in class, except it would be a lot more fun because there'll be a lot of clapping and cheering and calling people forward and all stuff like that. But well, we have to make do. It's the lockdown, so all right. So let's go through a detailed look of what actually happened there in terms of what's going on inside the PC. Okay, so I'm going to show this. Here. Okay, I'm going to show this step by step. First, we have that Fred and Ahmad are declared. So Fred and Ahmad, they're declared as type integer. So we see integer, and they have some address. Okay, in this illustration, we are using the old 8-bit version. And in fact, if you notice, this is the original ANSI C code, not C++ code. But it does exactly the same thing as the C++ code that I shared with you earlier. So anyway, Fred and Ahmad. Here's Fred and here's Ahmad. They have no values yet. Now we go to Jim equals 3. Int Jim equals 3. So we have Jim, it's an integer. A new memory location is allocated for it and here's the value 3. So we draw a box with Jim as the name and the value 3. Now we go to Zarina. Int star Zarina. So Zarina, you see the star, it's a pointer, specifically a pointer to integer. And its address is somewhere else. And so we have a box. And since it's a pointer, instead of having a value inside, we have a circle. Then we have int star Husna equals Ahmad. Equals ampersand Ahmad, which means address of Ahmad. So we have Husna pointing to Ahmad. So in actuality, what we do is we take the address of Ahmad and we put it as the value of Husna. And now we have int star star poly. So poly is again a pointer, but this is a pointer to integer instead of just pointing straight to an integer. Now, Fred equals 1. So we assign the value 1 into Fred. So you see, in memory location FFF0, we now have the value 1. In the VP diagram, we draw it as a 1 inside the box called Fred. Ahmad equals 2. So now we put 2 inside the box called Ahmad, and which in the memory of the computer, the value 2 gets put into the memory location where Ahmad is. Zarina equals ampersand Fred. This means we take the address of Fred and put it into the variable Zarina. So address of Fred is FFF0 in our 32-bit example here. We put it inside the value of Zarina, which means that Zarina, being a pointer to integer, is now pointing to Fred. Zarina pointing to Fred. Poly equals address of Zarina. Poly is a pointer to integers. So Zarina address is FFF6. We put that into the memory location of Poly. In the VP diagram, we show this as Poly pointing to Zarina. Then after that, we just print everything out. Oops. Okay, so that was actually what's happening inside the computer memory. So at the end of running all this, we can visualize it. Remember the first question I asked? How can we visualize this using a VP diagram? This is how. Okay, we have Poly pointing to Zarina, Zarina pointing to Fred, Fred has 1 in it, Husna pointing to Ahmad, Ahmad has 2 in it, Jim containing 3. And for the next question I asked, what does ampersand mean? So ampersand is asking for the address of whatever you're putting the ampersand of. So that means it is getting that value of the address memory location. So for example, Zarina equals ampersand Fred. So Zarina points to Fred. Ampersand gets the address of Fred. It places it in the pointer containing Zarina. And so this is saying the address of Fred is placed in Zarina. So in the VP diagram, Zarina points to Fred. What does star mean? Well, star actually has 2 different meanings. One is when you have it in a declaration. The other one is when you have it somewhere else than a declaration. So when you have it in a declaration, for example, int star Zarina, this means that we are declaring a variable. The variable is of type pointer to integer. What Zarina can point to is an integer. Oh my, something went wrong and my picture disappeared. Oh well. My camera disappeared. What does star mean? Let me try and get my camera back. I'll do this, troubleshoot problems, and next. Detecting problems, and there we go. My camera's back. All right. Okay. So we continue here. What are the steps in using variables and pointers? Well, first, you must declare all your variables and pointers before you use them. They don't exist yet until you declare them. Then you need to initialize them. Initialize means put some value in there. Then you can use them. Okay? You can use them to do stuff. you cannot initialize before declaration because the thing doesn't exist yet. It's like you haven't made the box yet, so you can't put something into the box. Okay? You haven't made that container yet, so you can't put something into the container. So that's why you must declare first. And you should not use before initialization, because when you first make the box, it doesn't contain anything meaningful. Actually, in real life, in a computer, it contains whatever random thing happened to be in that memory location. So it could really mess up your program if you start using it without having a specific value there. So how do I declare? I say the type, for example, integer, the name, for example, PTR, or the name here, VAR, and you could put a star if you want it to be a pointer, and don't put a star if you don't want it to be a pointer, if you want it to be a variable. So this is that pointer indicator. What types can we do? Well, you can put those fixed point variables like int, car, long, short. You could put user-defined one. You could put floating point variables like float and double. And later on, you will learn how to make user-defined types as well. So how do I initialize? In C++, you can initialize within a declaration or after. So if we set Fred equals 1, here we are doing it, declaring it after it's been declared. You know, earlier we said int Fred, and then now we say Fred equals 1. But Zarina, or in Zarina equals ampersand Fred, we have declared Zarina earlier, and now we are saying Zarina equals address of Fred. So the address of Fred gets put into Zarina. But we can also declare within declarations. From my example, we had int Jim equals 3. There we say int Jim, which is declaring Jim, and then equals 3, which is putting in initialization of Jim. So the value 3 gets put into Jim. Or, as in our example, we had int star Husna equals ampersand Ahmad, which means that we have declared Husna is a pointer to integer, and then we say take the address of Ahmad and put it into Husna. So we take the address of Ahmad, which in this example is FFF2, and put it into Husna. Here we have that same thing, int star Husna equals Ahmad, as which is within declaration, and putting it as following declaration. We could say int star Husna, and then later on saying Husna equals ampersand Ahmad. It would end up being the same thing. There's also null initializations. It is important to initialize all your variables before using them. So one way is to just initialize them when you declare to null. So int Fazli equals 0, int star Azura equals null. So this would make Fazli already have the value 0, and it would make Azura already have the value null. Remember, null is just 0 for pointers. So, very important, initialize all your variables, initialize all your pointers before you use them. So one way to make sure of that is just when you declare initialize. So some people take this practice. Now remember, especially for pointers, a pointer pointing randomly is dangerous. It may actually be pointing at your OS. In the old days, you could actually mess up your computer because it could be pointing somewhere in your operating system, and then you go and mess up your operating system. Your computer crashes, or the whole computer, you get blue screen of death. Now, in modern times, we have something called memory protection. So all it does is it causes your program to crash. In a modern computer, you get a segmentation fault. Okay? The error that you get is a segmentation fault. It crashes your program, only your program, not the whole PC. Okay, it just crashes your program, which is a lot better than crashing your whole PC. In the old days, you crash the whole PC. That's bad. So modern computers, they have memory protection. They divide the memory into different segments and they allocate certain segments to your program. So when you follow a pointer that's going out of your segment, you get a segmentation fault. And that means that your program will crash, but not the whole PC. So you won't mess up your whole PC. So it's a lot safer these days. Okay, what does star star mean? It has two different meanings again. Just like star had two different meanings, star star also has two different meanings. When you put it within a declaration, you're declaring a pointer to a pointer. Okay, so in star star poly is a pointer to integer. So for example, you could point poly to Zarina, which is a pointer to integer. So it declares that poly will point to a pointer that points to an integer. In this case, Zarina. Okay, you cannot point poly directly to Fred because it's a pointer to integer. Fred's not a pointer to an integer, it's an integer. In a declaration, star star means we are declaring a pointer to a pointer. In elsewhere, star star means dereference the pointer and then dereference that dereference. So as you saw in the animation, first we were at poly, we dereference it, it goes to FFEE, which is Zarina, and you dereference it, it goes to FFF4, which is Fred, and we finally get the value 1. So in the VP diagram, it's following the arrow twice. Follow the first time, you get to Zarina, follow the second time, you get to Fred, and you get the value of 1. Can we write ampersand, ampersand? No, you can't. You can't because how can you get the address of address? You know, the address of Fred, for example, in our example, the address of Fred was FFF4. But what's the address of FFF4? FFF4 is not a contents of something. I mean, it can be put as a contents of something, but you can't get the address of it. It's just a number, a special type of number, which is an address. So, for example, why doesn't it make sense? For example, you could put FFF4 and Husna, Zarina, and June, all pointing to Fred. So what's address of Fred? It makes no sense. Is it Husna, is it Zarina, or June? It doesn't make any sense, right? There's no unique answer. So how is memory allocated? The compiler usually allocates memory contiguously. That means all stuck together, one next to another, okay? In this example, we are using 2 bytes because it's using 16 bits addresses, and the pointer uses 2 bytes. Note that the order is not related to the order declared, okay? It's not necessarily in the same order as the order declared. Okay, where would I need pointers? Well, you need them in functions when you want to modify the value contained in a variable, because it's like a function is a different room. So if you have a phone, okay, if you have a phone, okay, phone, okay. If someone is in the same room as you can talk directly to them, right? Having the address is like having the phone number of that person, and you can call that person to talk to them even if they're somewhere else. So you can like WhatsApp them, or you can call them, right? So that's having the address. It's like having their phone number. And you need a pointer in the function to hold the address, and then you can access it to another place. And you also need it when you're implementing other data structures, because you need to refer to those other things. So later on, we will look at how that works out. So meanwhile, let's look back at this example. Can we say int star 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 Rachel? If so, what can Rachel point to? Well, the answer is yes, we can say int star star Rachel. Rachel can point to Polly because what does int star 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 Rachel mean? Int star 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 Rachel means that Rachel is a pointer to a pointer to a pointer to integer. So it needs to point to a pointer to pointer to integer. Well, Polly is a pointer to integer, so Rachel could point to Polly. Okay, so this would be what it looks like in a VP diagram. Rachel would point to Polly, Polly point to Zarina, Zarina point to Fred. So what happens if I print Rachel, the address of Rachel? What happens if I print Rachel? What happens if I print star Rachel? What happens if I print star star Rachel and star 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 Rachel? Well, if I print the address of Rachel, I would get the address of Rachel, FF whatever, okay? If I print Rachel, I would get the address of Polly because Rachel contains the address of Polly. If I print star Rachel, I would get the address of Zarina because I follow this arrow, find what's in there, which is the address of Zarina. And if I print star star Rachel, I would get the address of Fred because I look in here and see what's in Zarina, it's the address of Fred. And finally, if I print star 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 Rachel, it'd be Rachel, go to Polly, go to Zarina, go to Fred, which is 1. Another example, I'm going to declare ampersand initializing a variable pointer pair and print a memory location and contents and print the results of ampersand star and star ampersand acting on that pointer. So here are the questions to think about. How is memory allocated in this example? What is the process the computer goes through to print ampersand star PTR? And what's the process the computer goes through to print star ampersand PTR? Let's look at the code. Okay. We have declared a variable called variable. We've declared a pointer called PTR. We initialize the variable to 7 and we initialize the PTR to point to variable. Okay? And then we print everything out.
Now let's examine more closely what happens when it prints out. First, we have the name, address, and contents like before. And here we have var is at FFF4 with the contents of 7. PTR, you remember, we pointed to var. So although it's at FFF2, its contents is FFF4, which is the address of var. And then when we said ampersand star PTR, we got FFF4. And we said star ampersand PTR, we got FFF4 as well. So is it the same thing or is it different? Well, let's take a closer look. Here is what's actually going on. You see, after the declarations of line 6 and 7, we have var, which is of type int, which has the address FFF4 and doesn't have a value yet because we haven't given it a value. And then PTR, which is of type int pointer, which is at address FFF2, again, it has no defined value yet because we have not yet given it a value. Then after lines 8 and 9, they are initialized. So var equals 7, so var at FFF4 has the value 7. And PTR equals ampersand var, which means that PTR at FFF2, now you take the address of of var, which is FFF4, and put it in here. So what's going on?
So how do we calculate ampersand star PTR? Ampersand star PTR means that first we dereference PTR. PTR, dereference is FFF4, so we look in here. And then we get the address of this thing. What's the address of var? It's FFF4. That's how we got that FFF4. But how about then, so this is what's going on. We first dereference and then we get that. How about this one? Star ampersand PTR. First we get the address of PTR, which is FFF2. Then we dereference the address of FFF2, which is FFF4. So we got the same value, but we got them from a different place. Okay?
So in summary, what we have covered in this lesson is, firstly, we've covered the building blocks for data structures, which is variables and pointers. And in variables, we've got two different types, fixed point and floating point. And pointers, we have these special symbols for accessing them. There's the asterisk or star, which means if you are declaring, it is to declare a pointer. And if you are using, then it is to dereference the pointer. And ampersand, which is to get the address of a variable or pointer. And we draw all these using these variable pointer diagrams. So that's the end of our lesson. We'll see you next time. Bye.